Good. Thanks for introduction. And the question is, can imports hurt your build and speed size? And the short answer is yes. And the long answer is 25 slides long, so we can get to it shortly. I'm Vojtech Masek. I'm speaker, I'm GD for Angular, and I also organize a meetup in Brno, which is a city very close in Czech Republic, like second largest city there. Have you ever been to Brno? You should. Yeah, Brno is great. It's like a cheaper version of Prague without tourists. No tourist trap, it's amazing. It's like, Michael really likes it there. He goes regularly. So, yeah, and we organize a meetup there about Angular and about beer, and we take both very seriously. So it's usually a very good, very long meetup with karaoke at the end, so pretty similar with what you have there. But with actually, you know, like beer pipe, keg, not like a bottles or cans, like proper beer, you know, Czech Republic. So let's get to the Angular part, or to the JavaScript, TypeScript, because I will not be talking that much about the Angular, to be honest. It is not specific to Angular. This topic is specific to JavaScript and TypeScript ecosystem. So let's start with a little bit of history. It will be a short quiz, and you will see pictures, and feel free to, you know, try to tell me an answer, and whoever guesses right will get the token for the raffle. Damn. Let's pretend it never happened. So let's have a different kind of quiz. So do you know what this is? What this is? COVID? No, it's swine flu. Who is this? Barack Obama. True. Bitcoin. Okay. This person also like is pretty famous, and he died in that year, so it was pretty sad year all along. Like there was also some other things that happened. For example, this plane landing on the Hudson River, brutal ground shaking. What is it called? Like earthquake. Thank you. In Italy, it was not good. And why I have this is because of the year. So who saw it can shout it now. What year is it? Yes. And in this year, now actual question. What happened in this year? Besides all these things. Something important. What? Angular?
No.
Nah. What was it?
Launch?
No. TypeScript, no. Imports. Good thinking. You are close. You're close. So, CommonJS happened. CommonJS happened. It was developed in that year, and it got very popular with Node.js. And with imports, you were very close, because this is actually the time that some specific keywords were introduced. So a special variable called exports actually happened in this year with CommonJS. Before that, it was not really. There was not a simple way how you can export code, so we can do imports, so we can, you know, do all the domain-specific code organization. Not possible in JavaScript. Like before this year, before CommonJS, you just had, you know, a huge file and you were happy with it. And there was also this special function called require, because when you export, you also maybe want to require. So this all happened in that year. And now we get to how the CommonJS itself works. Does everybody know what CommonJS is? Like how deep I need to go? So we are all using it probably to this day, even though you shouldn't. We get to that at the end. Let's see how it works. So it's the classic JavaScript thing where you have all the requires and exports, and how you can already tell the file that you are mentioning in the require function is required. And what does it mean that it is required? It means that it will execute, and the exports are synchronously waiting until the file is there. So in theory, if the file is not there, your code will do what? It will wait for it forever. Like it will synchronously wait. Maybe now there are implementations that will time out eventually. But back then it would just wait for the file to be there. Why would it do that? Because it was designed for server side. It was designed for running JavaScript on a server. And fun fact, it was even called server.js. So it was not called CommonJS or something like that. It was called server.js back then. And everything you did, you were just expecting things to be there locally. That's how it was designed. And it was later picked up by browsers and somehow, started to work. And that was just because the require, as I already said, was a blocking operation. So in browser, eventually, whenever you would require something, the request would be made to the server and it would block the execution going forward. That's how it worked. To this day, some of these websites are, selling you flight tickets and, I don't know, taking your healthcare information. So it works still, but it's not ideal. And why is it not ideal? Because we have better things, to use now. We have ESM, and overall, it is not designed for browsers. So we get into whys later. I will not do the same mistake again. So here you have a beautiful quiz of what happened in this another year. Can anyone guess any of the images? This one is the easiest. What? Hub? Oh, no, it's not Hub. Horizon? It has something to do with a planet that was not really a planet. So they discovered that Pluto is not a planet. And yeah, then there was this German pilot who decided to, crash into the Alps. So overall, very interesting year. FIFA was shown as a very corrupt organization, interestingly. What else happened is obvious, or I will ask that. Do you know what else happened or what year it is? Maybe let's start with the year. 15? 15. Very good guess. 15. It is 15. So what happened in 15?
Imports.
Import. Again, you are very close. Very close. What exactly happened? Webpack? No. So it's 15. ESM happened. ESM itself. So this is the year where we got the ES6 naming, and this is the year where we actually got the ESM as a standard of ECMAScript modules. Before 2015, we had nothing. Before 2015, we had the CommonJS, and it was not good. So ECMAScript modules got introduced. That doesn't mean that everybody started using them. They were introduced. The import and export top level keywords were added to JavaScript. So from this point, you could not name something import or export. Before that, you could. So now you cannot. This is how we see TypeScript now. So this is very closely related because TypeScript actually decided to use import-export before ESM was even standardized. So we can be thankful that they didn't decide to use some else, like some different keywords, because that would be horrible. It was designed from scratch to work in browsers and asynchronously. And we'll explain that later, like how. So full ESM support only landed in Node.js, in Node 20 in 2020. So it's pretty recent. Like you can probably imagine that it really got hyped to that much that we only have like 4 years of actually having that available in Node. So you can imagine, how not available it was in browsers 2 years ago with Safari or other things. But now we live in a world where there should be no reason to not use ESM. And we can explain how it works, because it works a little bit differently. There are these subtle differences which actually make it horrible for JavaScript developers to live and use both of them. Internally, it uses top-level await to do all of the imports. Do you know what top-level await is? So it's like when you do await in like asynchronous functions in JavaScript, but on a top level, not async function, but outside of the scope of any function or class or whatever. That's how every import is internally evaluated. When you write import, you can basically, like behind the scenes, there is await import. It comes with dynamic import. Why? Because all imports already work in the way where they are basically somehow internally, promise-like, and with dynamic import you can dynamically import stuff. You can do it on runtime conditionally. It's really fun. If you never use dynamic import, give it a try. It's great for runtime or performance, like bundle size optimizations, because you can really slice things out and be sure that they only execute when they are needed. So all imports only execute once. This is pretty important. Like with this sentence, we will move on to many code examples and whatever, and you have to remember ESM executes once. Every time you put import somewhere, that import is executed, and it will never be done again. In the same context, of course. There is an interoperability problem in the JavaScript ecosystem. We can call it the biggest divide of the JavaScript community. So the biggest divide itself is the divide between should I use CommonJS, should I use ESM? Why? Because of obvious problems that we touch on later. With ESM, you can safely import CommonJS, it's fine. Somehow you can do it. But once you import CommonJS with require, then you can no longer import ESM again. So it's complicated. With CommonJS, you can import ESM, but only if you wrap it with dynamic import or equivalent functionality. Again, very weird thing to do and to remember when you are actually using both combined. And when you are already using both combined, you also need to take care of one more thing, and that is dual package hazard, because you can import both at the same time. You can, import library that has both implementations with similar looking syntaxes, and suddenly it's twice in your code base. And then you can think of it like, maybe it's a chart library, and I use some global configs for that chart library, so it, I don't know, does something by default, and suddenly this config, doesn't work when I import it differently somewhere else, because it's a completely different library from the perspective of bundler. It doesn't know that it's the same package. It's a very, very hard bug to debug, very hard bug to realize it's happening. People don't usually check the imports first, and even if they do, most of them don't understand that, like from that context, it could be so breaking. Never mix requires and imports in your code. Like if you have, for example, same code, same file where you can see require and dynamic import, it may be source of some problems that you don't realize you have. So compilers play very huge role in what you are using. Do you know what you are using? Do you know what, like, if you are right now in Angular using CommonJS or ESM? Who knows for sure?
Mostly ESM.
Mostly ESM. Why?
Because it's asynchronous.
Which bundler do you use for Angular? There are two currently. It depends. Oh. So does everyone know that Angular currently has two bundlers? One is Webpack, one is ESM or ESBuild. Obviously, ESBuild uses ESM. Does Webpack one use ESM? You can easily check it. It depends on the version, of course. You can easily check it, check your output. If you see require in that output, you are not using ESM. So it's that easy to check. But I think it's Angular 9 plus, you are using ESM, no matter what. It's when the dynamic, how was it called? The polyfills double loading thing was introduced, the conditional polyfill, something like that. From that point, you are using ESM. So, or old browsers are using CommonJS, of course, but new ones are not. So, with ESM, it is slower for larger apps. And I don't mean slower in build, I mean slower in execution or in first start, in the initialization. Why is it? So, the entire module graph needs to be loaded when using the whatever you are trying to import, or awaiting the import when it's dynamic. So the whole module graph needs to be constructed at that point of time. What does it mean, simply put? The module graph is everything that you can get to from the point you are importing a file to whatever that file imports, that file imports, that file imports, up until to the end where there are the actual statements and exports. So this is the module graph. Everything is jumped, like in a network when you have to go from a router to router. You do this with importing files. Every time you mention a file somewhere, you are importing it. The Webpack itself is file-based import. The ESM is also file-based import. It will do it like that. It will jump from one end to the other and see everything. Everything is visited. We will see examples later. Even if if you wrap the package with dynamic import, it basically returns a promise. And this promise is later on, awaited and only executed once, as I said. So every time you do dynamic import something, like the same library, it will never be dynamically imported again. It will just reuse the same thing again and again. It's not an actual promise that would, fire again. It just looks like that. And the most important thing is that if you really understand how ESM works internally, you will realize it's slower by design. They actually made it like that to be slower. They are trying to work on it to actually enable some of the features that you would normally have with require or with CommonJS. So it's not that slow, obviously, but we can explain why is it. So it's 2 passes are needed to bind imports to exports. What does it mean, that 2 passes? Like if you have a file and there is something written, something exported, and then actually imports are evaluated, it will go through this 2 times. In CommonJS, it would just do it once and hope something is out there. In ESM, it needs to be sure that thing you are importing is there. If it's not, it will not build. You will have to do a real magic in configuration to actually, tell it, please ignore this library because I built it elsewhere, and I will provide it to you as a minified JavaScript. So you will really have to make sure that compiler knows things are there. The entire graph, as I already said, needs to be parsed and analyzed. So it will not do that only for the top imports. It needs to know that everything you are doing in the whole chains is actually correct. Even in the libraries you are using, it needs to be sure that the thing the library is importing actually exists. So the whole graph is parsed and analyzed. And then, only then, the code is evaluated, only then everything is correctly put together, and only then compiler actually, not compiler, the executor in the browser or in Node.js actually does something. This split of first parsing it and making sure, and then doing the rest, is actually what makes a feature that is called live bindings possible. I didn't know before researching this what live bindings are. Does anybody already know what live bindings are? No, beautiful. So we will have a little bit of fun. We have two pieces of code on one side. But wait, it's okay. So left side is ESM, and the right side is CommonJS. And it's basically the same code written twice in different syntaxes of export. And what I'm about to ask you is, what are the outputs of these pieces of JavaScript? What does the CommonJS output and what does the ESM output? Who wants to give it a try? And those ones who know, because they've seen the presentation, should not answer. If you cannot see it, it's simple. It's exporting variable count that is 1, then having an increment function which does the prefix incrementing, and then actual console logging of the count, incrementing, again console logging. So I'm looking for two numbers. What will be the two numbers outputted here and two numbers outputted here? 1, 2, on which side? Both? Left side. 1, 2, and here 1, 1. Okay, so 1, 2, and 1, 1 is one guess. Is there any other guess? 2, 2 on both sides? Okay. So let's see the answer. It's 1, 2 on ESM and 1, 1 on CommonJS. So what did I do? Did I break it completely? No. It works. Good. So why is it? Why is it that ESM will actually output 1, 2 and CommonJS 1, 1? So the simplest answer is memory. If you look at it and try to come up with the reasoning, you can say, is this count here actually the same as this count here? This is where you get 1, 1. So no, it's not. This is you are assigning a value here to another variable that you are exporting. So it can never increment this, obviously. If you look at it from this perspective, it has nothing to do with anything else. It's just the memory thing. But this is actually what makes it possible in the ESM, because you are directly exposing this part of the module outside, and you can do whatever to it. If it's not a const, if it's let, you can increment it. And this can be interesting if you need that feature. I don't think it's a good pattern. I don't think you should actually start using it or have it this way. But there are, let's say, if you know some things that check your performance and have some arbitrary timings somewhere saved and then re-export it. It can be pretty useful for very specific libraries, or for some kind of seed to be exported to multiple and then incremented. Very niche requirements, but it can be useful. So these are the live bindings. Let's go there. If we forget about all the problems that ESM and CommonJS has, we can think of a bun. Have you heard of bun? So bun is a beautiful thing. Why is it beautiful? Because they actually fix this problem. They don't have this problem in BAN. They support both ESM and CommonJS at the same time. There are no problems between import and export. You can use whatever you like. And if you ask how, the answer is simple, because they are completely ignoring the spec. Like, they do not follow the spec. They just do it themselves, in their way, completely re-implement it and just interpret it as it should work. So in ideal world, it would be done like that. But since JavaScript actually implements some of the specs and follows it and supports it for a long time, it doesn't work like that. Never mind. We can use BAN in future. For example, I've seen that NX 19.5 actually supports BAN as a package manager. And I also think it also supports it for for runtime. Instead of writing npx, you can write BAN execute or something. And yeah, it's pretty nice. We can get there soon enough, I would say. Another 4 years, and we don't have this problem. So the import system just works. Let's end with that. Now that we are out of the basics and how the systems of imports work, there is a question: should I use bundler if I have ESM now? Like, I could just use ESM. I would type or refactor all my code base to have MJS instead of just JS. I would do dynamic imports everywhere, so I would take care of everything manually. Do I need bundler? Do we need bundler in Angular? Can we just use ESM for it? Why would we use ESBuild or Webpack or Rollup or whatever? Well, so answer is simpler. Again, loading speed actually matters, and the loading speed, if bundling, is much better if you actually do it correctly. So the import and export syntax is analyzable. You can tell, the bundler can actually tell you pretty easily if you are doing something wrong. There is static analysis available. It's much faster than finding out in the build process itself. Bundles actually optimize code. So you don't have to take care of these things manually. Otherwise, you would have to manually, take care of each of the unused code in your whole application. Bundlers do that for you mostly. Yeah, they are just eliminating using multiple strategies. Code tree shaking be one of them. I have a whole another hour-long talk about it, so let's not go there. And we can always ask, what would Chrome team do? So they would recommend you to still keep using bundlers, at least for the production builds. And this is why this simpler, small, not that readable graph. First one is unbundled. So blue, or I don't know what the color is, I'm colorblind actually. So this part is idling, this one is Blink engine, this one is V8 actually running your code. So this is what happens if you have a application that has library of around 300 modules. It runs the whole, till you get to the end of execution, 200 milliseconds. Just that. If you actually don't bundle, but have module preloads, so eliminate the time it gets to download the things, you are 170 milliseconds. If you bundle and not optimize, do not tree shake, still have unused code, still have things that you don't really need, you are at what? At 70, 80 milliseconds. And if you bundle and optimize, you are under 50. This is an example benchmark where they actually tested of how an application normally looks and included these 4 steps, checking how long does it take to actually execute the whole code. Just based on this, I would say, keep on using it. Even from my own experience, I would say, do not ditch the ES build or Webpack. Just be glad that any post processing is actually happening because your application is actually usable thanks to it. Now we are getting to a topic I also included because it's closely related, bearer files. Do you know what bearer files are? Index.ts, yes. Index.tx, index.js. Do you have these files in your code base? A lot of them? Not a lot? Did you already find out? Okay, some of you did. So they actually cause problems. And what problems do they cause? I think we will have two separate problems, so let's get to it. We have this code. So on one side, there is a bearer file, and on the other side, there is something that we will call stacked imports. Yeah. So if you re-export things like that from your library, you are using bearer files. It actually doesn't have to be called index. It can be called whatever. Index is just something that will provide you the feature that you don't have to write the name of the file because it just takes the name of the folder. But you can name it whatever. You can call it, public API.js and then re-export things. This is also a common pattern in libraries. So, two approaches. The problem itself. Tools are very slow if you have a lot of bearer files, and I will explain why. It has an impact on the size. Like suddenly you are in an environment where whatever you do, whatever you add actually matters, and you are just letting the bundler, as I already explained what bundler is, you are just letting the bundler do more and more assumptions about your code, because you are grouping things together based on what you are assuming they should be, but you are not really thinking of like, is this actually used and imported together? Do I need, this pipe with this button? Why they are in the same library? So they have the bundle size impact, and again, there will be separate slide on it. And it's a lot of boilerplate. Like you probably already been in a situation where you change something and then it doesn't work because you didn't change it in some folder somewhere where it's re-exported, and some people re-export it like, way far in a completely different galaxy, Suddenly it's a different NX library and it re-exports something from the root. It can happen, like some people do that. And you know what also does that? IDEs, when you move things around, like they tend to change and keep the refactorings in a way where it goes through the code review somehow, and suddenly you are not following your module boundaries. So there is an impact. There is a common misconception where people think that modules load only when they are needed. That's not true. Every import is loaded, parsed, and executed. Once you do import in your code, it will be loaded, parsed, and executed. As I said, that's how things work. There is, nothing like this import will suddenly disappear. No, it would only disappear if everything in that import is 100% unused, 100% side effect free, and not needed at all, which is a rare case. That's only when you really take good care of your libraries. So there is a thing called execution order. That's why it cannot just disappear. That is a thing why it cannot just skip some things, because if you do this, you have a feature A that has a global this foo 1, 2, 3. Then you have a feature B that has a console log of that global this foo, and you have a feature C which just exports letter X with assigned value of 42. Then you have a bearer file with just ABC re-exporting, and then you have a main.js which just imports the X from the bearer file and logs it. What is the output of this one console log? or not one console log, what is output of this main.js? Like if I execute this, what do I get? Again, 1, 2, 3, 4, and 42. Exactly, yeah. You will get 1, 2, 3, 4, 42. And why is it? Well, because execution order. What the interpretation or execution does is, seeing the X and being like, it's from feature. What is feature? Feature is this folder, but it has index. So let's have a look. A, parsed, execute. A, assign to global this. B, log it. C, X, get it here, log it again. This is what will happen. If this would not happen, then things like prototype changing of, I don't know how RxJS used to work or many other libraries work to this day wouldn't be possible. Then global constants wouldn't be possible. You could not create things like polyfills. It wouldn't be possible. So it has to be done like this. Everything is visited, everything is executed. Once you have a simple console log somewhere, it's executed. Once you have a piece of code that steals your npm credentials, it's executed. Once you do that import. Once your library does that import, it's executed. You cannot do anything about it. Only way how it wouldn't be executed if it wasn't actually called and if the whole file was like completely stripped away by tree shaking, which can happen pretty easily, but only in small projects. Like if you have small projects, that's usually what people do to set up and verify what is happening. They have a simple project, just put few things there, and they are like, my bundle is in perfect condition. Like it cannot get any better. Why? Because it ran for 3 seconds and it got, to the best condition it could get mathematically. If you have a huge Angular project, chances are you are never getting with your bundle to a most perfect condition because it will just output something after a while. So it has an effect on performance. It is not important how many lines of imports does your component have. It is important how many files along the way are visited, because you need to take everything into context. So if you are writing pieces of components that have a huge import section on top, is that a problem? I would say it isn't. Keep doing it because your IDE is anyway doing the imports automatically and it is closed. Like usually it's collapsed and you never see it. You only see it when you have unused import and you need to delete it or something. So keep doing it, don't care about it. What is important of how many files along the way you need to visit. So if you get rid of the bare files, you are helping your own code readability, you are helping the bundler, and you are also helping the execution context so it doesn't need to do many things. And when we get to the effect on performance, I like to include a little bit of numbers. So there is an experiment. Experiment is 100 test files. And these test files actually run in 4 parallel test runs. And you can see how the time adds up after more and more modules are added when these 4 workers are actually used. So this is an excellent example of how your jest is executing your test, or how your ESLint is running your lint rules in parallel, or how your Cypress is doing things. So when you have 500, it's fine. What is 3 seconds? Also, this is not how long test run. This is how long test runs plus overhead of what the graph was doing, like what it took to construct the whole import graph. So take that in mind. It's probably like minutes of test plus 3 seconds. So plus 3 seconds, then plus 7 something. Suddenly it's minutes or minute. Suddenly on 25,000 it's 7 minutes, and on 50,000 it's 20 minutes of overhead. Of how long will your ESLint run of overhead, not the actual execution of ESLint. Why is it? Well, because each of these workers is creating its own module graph. And everyone you add, sorry, I will be very quick now. So every one worker you add, you are creating one more module graph. It's horrible. This is why your tools are slow. This is it. If it starts like if you are in a project of 50,000 jumps that need to be made through the files, you are looking at this. That's why your jest takes over in CI with 6 parallel workers. Effect on bundle size. Of course there is. They are known to cause optimalization bailouts. This is a quote from Angular team. I think in comments somewhere I have the issue. Your lib, if it's completely tree shakeable, it's fine. The thing is that your probably isn't. Like your libs are probably not perfectly tree shakeable. Let's face it. Most of the libs aren't perfectly tree shakeable. How you can achieve it? You can manually review and optimize your imports. Yeah, you can go through that, do the things you need to do. Once you put enough code, imports to barrel, the assumptions are made by the compiler. What I mean by this, compiler is not perfect. Compiler will do assumptions. It is not your architect. It doesn't know your application. It will, from the graph theory of mathematics, it will try to get you to the best output in a given time. It doesn't want to run for 6 hours. It wants to run for 8 minutes. You want it to run for 8 minutes. It will output something after these arbitrary assumptions are made. Any common jest is not reshaken. Remember that. What are conclusions? Some barrel files are fine. If you have tens of them, if you just export, really some public API somewhere, keep doing that. Once you have barrel file in every folder, you are doing something horribly wrong. If they serve for API restriction, it's good, but you can also use the enforce module boundaries, and you can actually start using the NX in a way where you name things properly. Like there should not be a library called design system. That's multiple libraries, of course. Like not all design systems should be exported as one thing in a barrel file. That's not how it's supposed to be designed. Executive use. Very serious slowdowns. Huge projects can be very affected. Test runners, linters, everything like that, especially. Final conclusions, bundle your apps, don't ditch the bundlers. Give it a good analysis once it's output something. Every new project is ESM project, and ditch the barrel files mostly. Start deleting them, ideally. And sort your imports. That's the least you can do. Everyone should sort their imports. This is a prettier RC plugin. You can have the presentation, copy whatever I put there. Even the little snippets of codes are also available in code panel somewhere, so you can run them, see what it's doing. It's fun. Thank you.